Dear students, today I am going to discuss the introduction of theory of structure, and the topic that I will cover in this will be kinematic indeterminacy, in which I will discuss about the degree of freedom for pin-jointed plane frame, pin-jointed space frame, and pin-jointed truss, and with rigid jointed plane frame, rigid jointed space frame, and few examples, typical examples, how to solve the degree of freedoms for that structures, and why it is needed. Dear students, I am going to take the first lecture on structural analysis first, which is very much essential for the competitions like UPSC, GATE, and other public service commissions, as well as your college courses. First, I would like to define structures. Civil engineering structures are created to serve some specific functions like human habitation, transportation, bridges, storage, etc. in a safe and economic way. A structure can be defined as a body which can resist the applied loads without appreciable deformation. For the analysis of these structures, different type of loads acting on these structures can be taken as for the analysis. These loads are dead loads, live loads, wind loads, and earthquake loads. Now, the classification of these structures, broadly two types of classification: statically determinate structure, where sum of horizontal forces is zero, sum of vertical forces is zero, sum of moments is zero. So in a structure, if this condition fulfill, then this is the statically determinate structures. So maximum 3 unknowns can be found out. When there will be more than 3 unknowns, then that type of structure is called statically indeterminate structure. Where more than 3 equations are required. These 3 equations, sum of vertical forces and horizontal forces and moments, including this, there should be 2 more equations if there are 5 unknowns. So that can be found out with the help of deflection or slope equation. So in this way, statically indeterminate structures can be solved. The methods by which we can solve there are broadly 2 methods. One is called the displacement method, other is called the force method. Displacement method, they are also called the equilibrium method or stiffness coefficient method. In this method, displacements of all joints, which are called degree of freedom, are taken as unknown. Slope deflection method, moment distribution method, Carney's method, stiffness method, etc. are comes under the category of deflection methods. In force method, they are also called compatibility method. In this method, action forces are taken as unknown, and additional equations are provided by the compatibility of the form geometry of the structure under the applied loads. Method of consistent deformation, 3-moment equation, column analogy method, flexibility method, Casting-Lans theorem, etc. all comes under the category of force method. These are also For this, degree of static indeterminacy is required. Now I am going to discuss about the kinematic indeterminacy or degree of freedom, how to find out these unknowns. So kinematic indeterminacy is calculated to find the number of unknown joint displacements, also called degree of freedom, needed to define a structure deformed shape, which is crucial for analyzing indeterminate structures, especially with the stiffness displacement method, ensuring the stability and determining how forces distribute. By summing up all potential points moments and subtracting these fixed by supports or inextensible members. So if let us take a example, if it is a pin jointed structures X and Y, this is pin jointed plane frame, pin jointed plane frame. Degree of freedom, how to find out degree of freedom? There will be extension in the X direction, there will be extension in Y direction. As it is pinned, therefore there will be no movement in this direction and that will be 0. So therefore degree of freedom for this is 2. In the direction of X, delta X, in the direction of Y, delta Y. Then come for the, if joint is rigid, if joint is a rigid joint, and again plane frame, rigid joint plane frame, this joint is rigid and it is a plane frame, then there will be deflection in X direction, there will be Y direction, as well as there will be, so here the degree of freedom is 3. Now let us discuss the static kinematic indeterminacy. In kinematic indeterminacy for a space frame. A space, so pin jointed space frame. Pin jointed space frame. Suppose this is the pin jointed. So this is a pin jointed space frame X, Y and Z direction. So displacement in X direction, displacement in and displacement in Z direction. And there will be no rotations in this direction. Here is also and here is also 0. So degree of freedom in this case will be 3. So this is the pin jointed space frame. So in pin jointed space frame, the displacement in X direction, displacement in Y direction, displacement in Z direction and other rotations are 0. So therefore the degree of freedom is 3. Taking the rigid jointed space frame, here the joint is rigid. This joint is rigid and therefore here the displacement will be X, Y and Z, and there will be the rotations. So degree of freedom in this case is 6. Degree of freedom is 6. So so how can you relate a general term for finding out the degree of freedom? Therefore, a general equation should be for degree of pin jointed plane frame, degree of freedom will be Nj minus R. N is the degree of freedom at a joint. Similarly, for rigid jointed plane frame, degree of freedom is equal to 3J minus R. So in this way, the use of degree of freedom to find out the number of displacement in the structures, only for a space frame, pin jointed a space frame. So degree of freedom is equal to 3J minus R, or rigid jointed space frame degree of freedom is equal to 6J minus R, because at one point there will be, at one joint there will be 6 degree of freedom. R is the number of reactions. R is the number of reactions. In this way, you can find out the degree of freedom of any structure. Now, come for the you can take the different type of examples and can find out the degree of freedom for that. Few examples we can take. Examples we are taking. First, I am taking for the pin jointed truss. Pin jointed truss. How to find out the degree of freedom in a pin jointed truss? Suppose this support is on the roller and this is on the hinge. This is the pin. All the joints are pinned. So this is the pin jointed. Pin jointed truss. We are going to interested to find out the degree of freedom. This is the degree of freedom is equal to Nj minus R for one. And as you know, for one joint, if it's the pin jointed plane frame, therefore the degree of freedom is 2, so we can give it 2J minus R. So what is how many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 joints. How many reactions? There are 3. 2 here and 1 here. 1 and R2 and R3. So there are 3 reactions. So we will minus it. So the total degree of freedom is 21. So each member is going to displace, either there will be compressive force or tensile force. These are the auxiliary force members. So each member, either there will be compressive or tensile, and each member will give you either extension or compression. So only one deflection will be take place. Means there, if there is 21 deflections, means there must be 21 members. So let us count there are 21 members or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. So in this way there are 21 members and there is 21 degree of freedom. If it is a statically determinate structures, then you can count the number of members. That will be the degree of freedoms, because each member either give you the compression or tension, extension or compressions. So in this the degree of freedom can be find out. Now let us take the another example of a beam. We can take a beam and let us find out how much the degree of freedom is. So one beam is, suppose this is on, and there is the one internal one is the roller, and this is simply supported. Now we're going to find out how much the degree of freedom is. So joint is 1 and 2 and 3. The beam joints are considered as rigid. Beam joint is considered as rigid. Beam joint is considered as rigid. Therefore, we can degree of freedom will be 3j minus r, because at one point, at one joint there is 3 degree of freedoms, which we already discussed. There will be 3. So now there will be how many joints? There are 3 joints. So 3 into 3, how many reactions? So here is 1, 2, 3 and 4. So there are 4 reactions. So we will get it minus 4. So there will be 9 minus 4. There is the 5 degree of freedom. So how this 5 we are getting? Well, let us take the example. So how we get this degree of freedom 5? Now let us draw the free body diagram and we can get it. It is suppose. So suppose this is the deflected shape. This is the deflected shape. Tangent to the deflected shape will give you the slope. Say this is theta 1, theta 2. Theta 3 and theta 4. So there are 4, and there will be axial deformation in this direction, x, delta x. So this is the, so how many degree of freedoms can count? Theta 1, theta 2, theta 3, theta 4 and degree of freedom x. So there are, this is the 5 degree of freedom that we can get it after analyzing it. So on the basis of the formula we get 5. Here also you can see that there is the 5 degree of freedoms. Now we can discuss if there is any internal hinge, how many degree of freedom will be. Suppose in the same beam this I am put the internal hinge here. So how many degree of freedoms? Let us draw the deflected shape. Because of this hinge, the parabolic shape is not, they will be straight like this, then will be this, then will be there. So this is theta 1. Because of this displacement here, suppose 1, 2, 3, 4. This slope and this slope will not be same because of the condition. It will be different. Support here is, it will hinge here a little bit to this is theta 2, 1. This will be different because the condition is here. The condition is simply here the rotation. Therefore, the condition different. So this is the slope. Like that thing. Here the slope will be different, and here the slope will be different. So at here there will be 2 slope extra. This is delta 2. So at this joint, because of this, they will, if they will be getting here, it will be different, inclined. Maybe here there will be like this inclined. So we can resolve in 2 components. One is x, another is y. So here there will be 2 displacement, delta x2 and delta y2. So because of this internal hinge, there will be 4 extra deflection here at this point. So that's why one internal hinge can create 4 additional degree of freedom. 4 additional degree of freedom. So therefore, if I'm going to find out, there were so 3j minus r, and therefore for one internal hinge we can provide 4 additional degree of freedom. So how much degree of freedom is 3? Number of joints is 3. We cannot consider the internal hinge in the joint. They are, because we are already taking 4 degree of freedom for that. Therefore, we will take only 3 joints. Reaction, their reaction is 4 reaction and additional 4 for internal hinge. So therefore, degree of freedom is 9. Total degree of freedom is 9. 5 for earlier and 4 for internal hinge. So this way you can find out the degree of freedom. Internal hinge has 4 additional degree of freedoms. Now this is the case of the beam. Now come for the frame. So frame, single bay frame, I'm taking single bay frame and drawing the deflected shape. This is the deflected shape of this. So here the slope is theta 1, say the same slope here will be, and same theta 2 here and theta 2 here. And this is the displacement. This displacement will be the same as this displacement. So this is the displacement. Delta joint is 1, 2, 3 and 4 joints. That is delta. Here this will be in the horizontal direction, delta x2, and there will be in vertical column in the direction of the column there will be axial deformation. So here also delta x2 and delta x3. Add 3 joint, delta x2 and delta y2. But in this direction there will be delta x2 and the column will also deform, axial deformation along the columns, that will be delta y2. So total, first we can let us find how many total degree of freedom is equal to 3j minus r, because this is all the joints are considered as rigid. 3 into how many joints? 4 joints. How many reaction? 3 here, 3 here, so 6 reaction. Degree of freedom is 6. Now you can see how much theta 1, theta 2, delta x2, delta y2, delta x3 and delta y3. So these are the 6 degree of freedoms from the deflected shape we can find out. If suppose we are neglecting axial deformation, then what will happen? The delta y2 y3, because they are axial deformation, there will be very negligible value, so we can keep it 0, and delta x2 and delta x3 will be equal, because the same condition of the support condition as well as the joint condition is the same, so they are x. So in that case, if the axial deformation is neglected, how many degree of freedom? So delta 1, delta 2 and delta x, only 3 degree of freedom will be there. So if anywhere in the question it is written that the axial deformation is neglected, then you have to give degree of freedom is 3. If it is not written, then degree of freedom will be 6. Now take another example. This the frame, and this is the hinge, internal hinge. Then how many degree of freedom? If I draw the deflected shape, this will be like this. Like this. So this is the theta 1, this is the theta 2, and this will be theta 3. Both will be theta 3. And there will be 4 internal hinge for this, and this will be 2. So degree of freedom for this case will be 3j minus r plus 4 is additional for one internal hinge. This is 1, 2, 3, 4. So for this hinge we have already taken 4, so no need to consider in the joint. So this will be only 3 joints, 1, 2, 3. So 3 into 3 joints, reaction is 6 plus 4. So how many? 7. There will be 7. So which one is 7? Theta 1, theta 2 and theta 3. plus 4 additional. Plus 4 additional. If I'm consider the other way we can solve these problems, we consider as a joint here, a rigid joint we consider. Then to make the rigid, one moment will be included. Other way is to find out of this. I'm making this as a rigid. So if I'm as soon as making rigid, there will be here the moment is 0. As when I'm making rigid, the moment will be added. So 1 r dash is called 1. 1 means moment, one additional moment we are adding here. So now we can, there will be 4 joint, and so degree of freedom will be 3j minus r plus r dash when we are adding. So 3 into 4 joint minus 6 plus 1, 7. So in this way we can find out, we can consider it as a rigid, and then that joint will be considered, and how many r dash will be, we have to add here, and that will give you the degree of freedom. So we can also solve by this way. You can consider it a joint, rigid joint, and then otherwise you can do, you don't consider it a rigid joint, you will hinge. 4 additional will be here, and in this way you can find out the required values. Few more complex problems I am taking. So let us solve that complex problem. Suppose this is a this is a pen, and all joints are pinned. So how can you find out? This will be degree of freedom is equal to two j minus r. Why 2? Because it's a plane frame, all joints are pinned up, and so this will be not treated as a rigid, this will be treated as a twin jointed. And so how many joints? 1 2 3 4 8. 1 2 3 4 5 6 7 8. There is the 8 joints. How many reaction? 4. So there will be 12 degree of freedom. In this way, all the problems can be solved taking as a degree of freedom. In this way, degree of freedom can be. So there will be 12 degree of freedom. So you can solve this problem. Another example I am taking. So this is the internal hinge providing hinge. So 1 2 3 4 joints. So degree of freedom is equal to 3j minus r plus 8, because there are 2 internal hinge, and the internal hinge provided, one internal hinge is provided 4 additional, the other will be 4, so there will be 8. So number of joints is 4, reaction 6 plus 8. So this is the total degree of freedom is 14. So So in this way we can find out any complex problem, we can find out the degree of freedom. In next video I will discuss the degree of static indeterminacy for beams and frames by Henderson's rule and method of joints. Few typical problems will be solved and discussed.